Now note, order matters. For all and there exists can be used together in a single statement. However, the order in which they appear is important. Okay, so for all integers n, there exists an integer m such that m plus n is a multiple of 5. Now that's true. Okay, so for all integers n, there exists an integer m such that n plus m is a multiple of 5. We could find one single example of that. That is true. If I put it that there exists an integer n such that for all integers m, n plus m is a multiple of 5, that would be false because we need it to occur for everything. Okay? And that's not going to be the case. So negating statements involving quantifiers, the negation of for all statement is a there exists statement, and the negation of a there exists statement is a for all statement. So let's look at the examples. Determine the negation for each of the following statements. Also determine whether the original statement or the negation is true, justifying your answer. So I've got for all integers n, 2n is even. Okay, so that means that the negating statement would be there exists an n, which is an element of z, it's an integer, such that 2n is not even. Okay, so the first one was for all integers n, multiplying by 2 will result in an even number. It has to. It's a multiple of 2. Okay, so the original statement would be true, as a resulting number would be a multiple of 2. If we look at the negating statement, there exists a number which is an element, which is an integer, such that 2n is not even. That's false. If we multiply any number by 2, 2 is then a multiple, so it has to be even. Okay, so the original statement would be true, as the resulting number would have to be a multiple of 2. Okay, let's look at the next one. There exists a real number x such that x squared equals -1. Okay, hopefully in the back of your head saying, well, that's not true, because if we square anything, we get a positive. But anyway, the negating statement, we started with a there exists, so it's going to be for all x being a real number, x squared can't equal -1. Okay, we know that's true. The negation is true, is squaring any real number will either be 0 or a positive number. Okay, so the negation is true, as squaring any real number will result in either 0, if the number is 0, or a positive number. It can't be -1.